Find the position of a particle at time t seconds, given that its acceleration is t, and that at time t equals nothing, the displacement of the particle from a fixed point and the velocity of the particle are 3 meters and 6 meters per second, respectively. That's quite a long sentence, but this bit here we can summarize as when t is nothing, the displacement is 3 meters. So when t is nothing, s is 3, and also when t is nothing, v is 6. So if it helps you get further through the question, write these things down to summarize and simplify. So let's have a quick recap. Differentiate displacement, you get velocity. Integrate velocity, you get displacement. Differentiate velocity, you get acceleration. Integrate acceleration, you get velocity. In this question, the acceleration is t. We want the position of the particle at time t seconds. So ultimately, we want the displacement. We're going to be integrating not once, but twice here. So velocity, which I'm going to call v, is the integral of acceleration, so the integral of t with respect to time. That's what the dt is telling us. So it's t squared over 2, and very importantly, plus a constant. You must not forget the constant here when we are integrating, vitally important. I've called it C1 because I'm thinking ahead. We're going to be integrating twice, so there's going to be 2 constants of integration. I'm going to call this one C1, I'm going to call the next one C2. Let's work out the value of C1. We need something that ties together t and v, and we've got it over here. When t is nothing, v is 6. Sub those in, and we get C1 is 6. So now we know the velocity in terms of time. So now we know the velocity is a half t squared plus C1, and C1 is 6. Now we can integrate that to get displacement, which I'm going to call S. So integrating half t squared plus 6 with respect to t is 1/6 t cubed plus 6t plus another constant. Looking back over here, we need something that ties together t and s. And here it is. When t is nothing, s is 3. Sub those in. Our second constant turns out to be 3. So to answer the question, find the position of the particle at time t seconds. So that's not a particular fixed time, that's a variable time. So our final answer is going to be in terms of t. And here it is. There's 1/6 t cubed plus 6t plus our constant 2, which was 3. And that is the position of the particle at any time t seconds.